Welcome to ProStep Digital Thread and Digital Twin Integration Strategy for Aerospace and Defense. My name is Brian Scouten, Director of Technical Presales at ProStep Inc. And in this presentation, we'll go through an overall strategy that ProStep utilizes in order to implement digital thread or digital twin integration for A&D. A little background about ProStep. We were incorporated in 1993 in order to provide interoperability in engineering and manufacturing data exchange. You see some of our owners on the bottom here, and in the lower left, about 15% owner is the ProStep IVIP Association, a nonprofit standards group that specializes in standards and best practices for interoperability, like Step 214 and Step 242 or REC-IF and other types of working groups. Something that makes ProStep fairly unique in the industry is our neutrality and our technology partnerships. So we don't resell any of these other vendors' software, but we partner with them in order to leverage the APIs of these systems so that we can provide interoperability. That enables our customers then to use the best tools for the job, not ones that are maybe prescribed by a specific vendor, but to get the data into the tools so that you can most efficiently and effectively use them. And that neutrality and those different technology partnerships we have really enables our core strategy, and that's using integration to enable people, processes, and software. And that starts with the people within your organization, and they might be within different domains, utilizing different software packages, and those packages and that data and those different domains might not effectively talk to each other to build that digital thread or to create that digital twin that you might have within the different systems. So what we would like to do is then utilize integration across these different vendor boundaries and across the different domain boundaries and capabilities that you have to create data flow and provide that kind of digital tapestry that you would in digital thread to move data across your product life cycle and to have a net result of a totally digitized engineering and manufacturing ecosystem using integration that still uses the tools that you use today in order to provide the capabilities that you need and develop a digital thread and digital twin. So for providing this interoperability between these different vendor systems, we really have 4 different types of strategies, and they all maintain that authoritative source of truth, meaning where the data is authored and configuration managed, like the repository of that data, and it's released from and updated to. That's where we want to then source the data as it goes through your product lifecycle. In order to do that, we have different strategies. First, replication, and this is the export from one system, map to the second system, and import to that system, and do that in a consistent and automated process. So, a typical example of this is from your product lifecycle management system, you need to release to ERP. So you have a release, that release then triggers the synchronization, and then you go ahead and bring the data into ERP. The second technique is using linked data, and this is like with a web link or URI, where you can point from the source system and you have just that URI information, but it points to other systems and data that's within those systems. You can do that with our connectors or with open standards like OSLC, and you can have kind of that digital thread built there. Now, this works well because it is a very lightweight integration, but sometimes it has some drawbacks because you can't actually utilize that data efficiently because it's not in the system that you're trying to use. It's just a view of that data into other systems. So if you want to use binaries within a CAD integration or something like that, you're not able to do that efficiently through linked data. The third, and this is sometimes categorized as another way of providing data, is migration. But we call this, in the digital thread world or digital twin world, platforming, right? Bringing the data into a single platform so that it can create the digital thread and digital twin within that. And that is, really an effective way to manage, the cross-domain, dependencies, is if you have it all within the same vendor platform. And we do a lot of migrations in order to bring data from different vendors into a single platform with a large volume of data. And fourth is collaboration. And this is kind of like a replication, but sometimes using native formats or neutral standards across a corporate border. So trying to bring automated processes in order to bring data either from one PLM to another PLM, or different types of systems into neutral formats so that it can be then consumed. And sometimes with IP filtering, with Delta, synchronization to understand just what's changed, because sometimes these are very large platforms and need the performance, something like that. So utilizing these different techniques, we're able to bring the data across the product lifecycle between the different vendor systems that you might use today in order to create that digital thread and to deliver that digital twin from engineering into manufacturing or sustainment, depending on the view of what that might be. We do that with our digital thread platform, utilizing replication where it's necessary, utilizing linked data, consolidating data with migration, or bringing data from partners and suppliers so that it's bringing it into your environment, or data from your environment into their environment, and enabling that type of data exchange. So the way that we can efficiently do this and bring data between these different systems is because we have one standard neutralized interface that we utilize in order to connect from the different APIs of the system into our digital thread platform open APIs. And so, on one side, we're implementing, the connectivity that's needed to go to SAP or Teamcenter or 3DX or Windchill or whatever that might be. And then on the other side, we've got a standard computational and informational data model and an interface that's used for all those. And so that's available to any of our customers because it's bundled with Swagger and Open API. And it could also be OSLC enabled for linked data with the ProStep OSLC provider. And because you have that standard interface, all of a sudden, all the tools within the digital thread platform can be utilized with the different system connectors. So those are Delta and mapping tools and other things, secure data exchange tools, transformation tools, all those things are very easily adopted because of the neutral data interface that we're using. Architecturally, the digital thread platform looks a little bit like this, where you're starting with that foundation of the data management systems and the authoritative source of truth at the bottom. And then we have those connectors that connect to them and then neutralize that data, and then be able to provide the data across between systems, or traceability, or do migration or data exchange, the different functionalities that are available in order to promote this type of digital thread and digital twin. Data that's available from the connectors, we're able to add the different services in order to perform the transformation or business logic that you need. So we've got a business logic orchestration engine powered by Camunda that enables complex workflows. We've got CAD processing and batch processing, managed secure file transfer, mapping, and other types of capabilities that we can then implement in the middle there, so that you can do any of these types of interoperability workflows that you're really looking for in order to provide data across your enterprise. Something that we've done for the last 25 years, but fits really well with aerospace and defense, is providing a modular open systems approach, or MOSA. The digital thread platform's already set up like this, and the practices that we use and the strategies that we employ fit really well with the 5 tenets of MOSA. So we use agile methodologies in order to make sure that we're employing modular and automated approaches with our CI/CD pipelines. We have a modular design with the digital thread platform. They're microservices-based components so that you can have flexibility for parallelization or failover, or speed up the development process and maintainability. We have open interfaces, so we've published APIs that are included with all the components so that you can use the components just as well as we use them. We're not trying to gate any of the functionality. We want our customers to use all the functionality. We promote open standards. We are ProStep, and that's in the culture of our company. So we want to have open standards be utilized as part of interoperability, especially in data exchange and collaboration between partners. And we think that with all of that, we can provide you with a more effective and efficient engineering ecosystem that will enable you to score better and have a competitive advantage to your business over your competition when you're trying to win new platforms. And this all kind of culminates into ProStep's integration solution concept for aerospace and defense in an integrated digital environment platform. And that's using the existing tools that you have in order to implement integration between them. So not rip and replace anything, right? And not have an impact to the different users that you have, but using our different digital thread platform products, OpenCLM, to provide traceability and configuration lifecycle management, OpenDXM Global X to provide secure data exchange and automation and transformation of data so that you can collaborate with your partners, and OpenPDM to provide integration workflows internally in your system so that the data can flow across the different systems within your divisions or domains or programs. This is entirely a transactional approach. We don't want to have any disruption to users within their systems. We want to make them more efficient within the systems they have by bringing the data to them and really getting away from any of those swivel chair type activities where they have to do data entry or draw data, but really bring the data to where they need to use it. And it's a flexible adoption that has high sustainability and maintainability because of the modularity of it. You can replace connectors when you're upgrading a system, or if you're adopting a new system, you can migrate data there, or kind of do that a la carte instead of exchanging all the point-to-point connections that you might have. So we think that this is going to give you a competitive advantage in bidding on your new programs within aerospace and defense. And remember that ProStep's here to help. So we've been around for a while. We've seen these different types of integrations, and we really know the best practices of how to do this cross-vendor and cross-domain integration. And so reach out to us, and we'd be happy to discuss, the challenges that you have and see if we have a solution that's good fit for you. Finally, thank you for attending. Again, I'm Brian from ProStep Inc. Reach out if you've got any questions or comments, and we'd be happy to hear about them. Thanks.